The universe is far stranger than we've ever imagined, and for centuries, scientists believed they had a grasp on its beginnings and its rules. But now, the James Webb Space Telescope is revealing a reality that defies everything we thought we knew. Ancient galaxies, forming shockingly early, glowing with light that should have been impossible to see, are forcing astronomers to question the very foundations of cosmic history. What if the universe is far older, far weirder, or far more complex than the Big Bang theory suggests? What we're seeing isn't just distant light, it's a challenge to our understanding, a glimpse into mysteries that could rewrite the story of existence itself. And as we peer deeper into the cosmos, one question lingers: are these early structures merely anomalies, or are they evidence of something fundamentally new in the universe? For decades, scientists believed the early universe was a quiet, dark place, filled with clouds of gas and scattered particles, slowly coalescing into the first stars and galaxies. The conventional timeline suggested that large, luminous galaxies couldn't form until hundreds of millions of years after the Big Bang, gradually building their stars over billions of years. But the James Webb Space Telescope has shattered this expectation. Peering deeper than any telescope before it, Webb has uncovered objects that are massive, bright and seemingly fully formed at a time when the universe was still in its infancy. These ancient structures challenge the standard cosmological model, the lambda CDM framework, which relies on cold, dark matter and dark energy to explain the universe's evolution. According to these models, there simply wasn't enough ordinary matter or time for such galaxies to exist so early, yet here they are, shining across 13 billion light-years of space, forcing astronomers to reconsider everything they thought they knew about the formation of galaxies and the timeline of cosmic history. The discoveries from Webb don't just push the boundaries of distance, they push the boundaries of our understanding of time itself. Every photon captured from these early galaxies is a glimpse into a universe barely 200 to 400 million years old, a period previously thought too young for such massive structures to exist. These galaxies aren't faint, primitive clouds. They're dense, star-packed, and astonishingly bright, indicating rapid star formation that defies the gradual build-up described by conventional models. In some cases, these galaxies have converted nearly all of their gas into stars in an impossibly short span, leaving almost no raw material behind. This rapid evolution suggests processes at work in the early universe that we don't yet understand, hinting at either unknown physics, accelerated cosmic growth, or perhaps a missing chapter in the story of galaxy formation. The implications are staggering. If these objects are representative of the early universe as a whole, then the standard model of cosmology may require significant revision, and the very notion of how galaxies and perhaps the universe itself formed could be far more complex than we ever imagined. What makes these discoveries even more perplexing is their sheer scale and organization. According to the lambda CDM model, forming such massive, luminous galaxies so early in cosmic history should have been nearly impossible. There simply wasn't enough time or ordinary matter for these star factories to assemble, yet here they are, glowing brightly across the depths of space. Some of these ancient structures appear already mature, with tightly bound stars and surprisingly orderly shapes, defying the chaotic, clumpy appearances we expected from the first galaxies. The chemical fingerprints detected through spectroscopy reveal elements heavier than hydrogen and helium, meaning multiple generations of stars may have already lived and died, enriching their surroundings in a cosmic blink. Every new observation forces scientists to reconsider the timelines and mechanisms of cosmic evolution. Are these anomalies rare exceptions, or do they hint at an entirely new framework governing the early universe? Webb's images are rewriting the narrative, showing that the universe's infancy was far more dynamic, violent, and complex than our textbooks ever suggested. challenging astronomers to rethink the story of how the cosmos grew from darkness into the luminous expanse we observe today. The implications of these early massive galaxies ripple through every corner of cosmology. If such structures could form just 200 to 400 million years after the Big Bang, it means the processes driving star formation and galactic assembly were far more efficient than previously imagined. Standard models assume a gradual buildup, where gas clouds slowly collapse over hundreds of millions of years, forming stars in a measured pace. Yet Webb's observations suggest some regions of the early universe were on fast forward, converting nearly all their available gas into stars almost instantly. This challenges assumptions not only about galaxy formation, but also about the distribution of dark matter, which acts as a gravitational scaffold. If galaxies could emerge so quickly, our understanding of the interplay between ordinary matter and dark matter may be incomplete or fundamentally flawed. The very chronology of the universe as we've pieced it together from cosmic microwave background radiation and theoretical models now faces scrutiny. Every glimpse into these distant galaxies reveals environments more extreme, luminous and organized than ever predicted, forcing scientists to ask whether unseen forces, exotic physics, or even entirely new mechanisms were at work in the cosmic dawn. The chemical composition of these ancient galaxies adds another layer of mystery. Spectroscopic studies show that they are already rich in heavy elements. Elements like carbon, oxygen, and nitrogen that are forged in the cores of stars and spread through supernovae. According to conventional timelines, there simply hasn't been enough time for multiple generations of stars to produce such a high concentration of metals. This suggests that star formation in the early universe wasn't just rapid, it was intense, prolific, and highly efficient. Some of these galaxies appear to have exhausted nearly all their gas reserves, leaving little to fuel future star formation, a behavior completely at odds with standard cosmological models. The presence of such chemically mature galaxies challenges our understanding of stellar evolution, nucleosynthesis, and the life cycle of galaxies. Each observation forces astronomers to consider scenarios they once dismissed. Perhaps there were previously unknown mechanisms that accelerated star formation, or maybe cosmic structures formed through processes we have yet to comprehend. The James Webb Space Telescope is revealing a universe that doesn't just evolve slowly over eons, it can ignite, flourish, and astonish in the blink of a cosmic eye. The implications of these discoveries extend far beyond individual galaxies. If massive, mature galaxies existed so early, it calls into question the timeline of the universe itself. Current models rely on a steady, gradual formation of structure from the Big Bang, but these observations hint at a universe that is far more dynamic, far more chaotic, and perhaps far older than previously believed. Some theorists are now exploring radical possibilities, including modifications to the standard lambda CDM model, or even alternative cosmologies like the cyclic universe theory, where our cosmos is just one phase in an endless cycle of birth and rebirth. The idea that these ancient galaxies could have formed and evolved at such a breakneck pace forces scientists to reconsider not just when structures appeared, but how the fundamental laws of physics operated in the early universe. Were there bursts of accelerated star formation driven by unknown energy sources? Did dark matter or dark energy behave differently at that time? Every answer seems to spawn more questions, and every new Webb observation adds layers of complexity. What was once considered settled science is now open to interpretation, and astronomers are left grappling with a cosmos that refuses to conform to expectations. The early universe, as revealed by Webb, is not a quiet, predictable place. It is a furnace of creation, full of anomalies that challenge our understanding at every turn. Even more puzzling is the discovery of supermassive black holes lurking in these early galaxies. Observations reveal objects with masses millions, even billions of times that of our Sun, existing just a few 100 million years after the Big Bang. According to conventional astrophysics, there simply hasn't been enough time for black holes to grow to such enormous sizes through standard processes like stellar collapse or gradual accretion. This forces scientists to reconsider the mechanisms of black hole formation and growth. Some propose that primordial black holes, formed directly from dense regions in the early universe, could be the answer, while others suggest entirely new physics at play. The existence of these colossal black holes alongside massive, mature galaxies indicates that the early universe was far more efficient at creating structure than previously imagined. Each new finding not only stretches the limits of our understanding but also hints at a cosmos far stranger, more energetic and more complex than we ever dreamed, compelling astronomers to rethink the very story of how the universe came to be. Adding to the mystery, the James Webb Space Telescope has revealed that these early galaxies are forming stars at astonishing rates, far beyond what current models predict. Some of them have converted nearly all of their gas into stars in just a few 100 million years, a process that should normally take billions. This rapid transformation challenges our understanding of galaxy evolution and star formation, suggesting that the early universe was a cosmic pressure cooker, churning out stars at unprecedented speed. Even more bizarre, the chemical composition of these stars appears unusually mature, with heavier elements present far earlier than expected, hinting at a previous generation of stars or processes we haven't yet uncovered. Every observation seems to contradict the timelines and assumptions that cosmologists have relied on for decades, forcing a re-examination of the models describing the formation of structure in the universe. As astronomers dig deeper, each new image pushes the boundaries of what we thought possible, revealing a universe that is not only older and larger than we imagined, but also far more dynamic and unpredictable in its earliest stages. The discoveries from the James Webb Space Telescope are reshaping everything we thought we knew about the early universe. Galaxies forming faster, larger, and more efficiently than predicted challenge the foundations of cosmology and force scientists to reconsider the Big Bang timeline, galaxy evolution, and the very nature of cosmic history. We are seeing evidence that the universe may have started far earlier, grown faster, and evolved in ways that defy our models, hinting at processes and forces still unknown. Each new observation uncovers anomalies that push the limits of human understanding, revealing a cosmos far stranger and more complex than anyone expected. As we continue to peer deeper into the universe, one thing becomes clear: the story of our cosmic origins is far from complete, and the mysteries Webb is uncovering may rewrite the history of everything we thought we understood about space, time, and the birth of galaxies.